Hi, my name is Doug Milford from Lambda Valley, and welcome to this video on why you should learn Rust. In this module, we won't be doing any coding, but talking more about high-level concepts and rationale for Rust. If all you want to do is get your hands dirty with code, feel free to jump ahead to a future module. In order to decide to pick up a new programming language, there has to be a compelling reason. In this video, I'll be talking about those reasons as well as some potential negatives. If all I do is tell you about the positives, then it's hard for you to make an informed decision. In the end, I'm confident that you'll find Rust to be a breakthrough in software development, just as I do. The big question is why you should learn Rust. What does it buy you? This is certainly not a comprehensive list, but here are a few things. Runtime speed is extremely fast. It's on par with C++ and oftentimes faster. Rust consistently benchmarks extremely high on runtime speed compared to other languages. It's one of the best. Safety, safety, safety. The trade-off decisions Rust has made it much easier to create programs that are safe to run. The confidence that I have that my program will not crash unexpectedly is extremely high with Rust. With other languages, no matter how good of a programmer you are, it seems there's always an axe over your head ready to fall any moment when you're presenting to an audience. To me, Rust is synonymous with confidence because of its focus on strictness about safety. End-to-end development. It seems that you need to know 3 to 4 languages to do a multi-tier application. Rust can be used end-to-end, including the web front-end. JavaScript is also capable of doing end-to-end development. However, JavaScript seems to drop the ball in all the areas that Rust excels, such as runtime speed, code correctness, etc. Rust blurs the line between web and native applications. With the rise of WebAssembly, also known as WASM, you can now develop in the same language that you would use for native applications. You get the speed benefit of the native application combined with the portability of the web application. Very powerful. Multiple cores can easily be tapped and utilized. With Moore's Law slowing or stopping in the near future, programming languages are going to need to utilize more cores in a safe, efficient way. Rust is on the front of that curve and is ready to scale to more cores. The compiler is very expressive and helpful. It will be your best friend on your journey to a better world. Rust also has an exceptional developer community. And last but not least, Rust has been recognized as the most loved programming language on Stack Overflow in 2016, 17, 18, and 19, 4 years straight. That win streak can certainly continue. It's the most loved language for a good reason. I mentioned that I would also talk about the negatives. The first one is learning curve. The learning curve for Rust is quite steep for both beginner and experienced developers. That's why I made this series, to ease the learning curve. I want you to love Rust as much as I do. The developer community is still small, so when you run into an issue, there's not a lot of existing resources. However, the community is exceptional regarding supporting each other. I've had Mozilla developers answer my questions directly. I felt humbled and honored to get that sort of interaction, but really, the community is just that supportive. Lastly, Rust is still maturing. The ecosystem is moving so fast that it's hard to put a stake in the ground on whatever external libraries you've chosen to include in your code. Sometimes your chosen tools become obsolete. I'd rather live in a growing, thriving environment, though, than one that's stagnant. So I've talked about the positives and negatives, but how does the Rust programming language do it? The Rust programming language is a different way of thinking about programming. At its core, it's a systems programming language that aims extremely high. Runtime speed, safety, code correctness, cross-platform, and more. I view Rust as the Superman of programming languages. It combines so many superpowers into a single body that it's almost not fair to the competition. And it does this by making significant trade-offs that other languages couldn't, particularly about memory management. This has huge ramifications for seemingly separate areas. So the key to why Rust can succeed in so many areas where other languages struggle boils down to this trade-off decision. It affects safety of the programming language, for example, the chances your program will crash or not, all the way to hardware efficiency and being able to naturally utilize more cores. What's the negative of the trade-off? You have to retrain yourself as a programmer somewhat. This dog needs to learn a new trick, but it's a very good trick. Again, this is not a comprehensive list, but here are some highlights of the trade-offs. Memory management is managed at compile time. There's no garbage collection and no need for garbage collection. This may seem odd to an experienced programmer. It is a difficult concept to get used to if you're coming from a different language, but it does buy you some very important things. The compiler can detect things earlier and prevent entire classifications of bugs. There's no such thing as a null. This one's a hard one for existing developers to wrap their head around, but it prevents all sorts of issues that could crash or corrupt the program. Once you understand the Rust methodology around memory management, this becomes a little more clear. And zero-cost abstractions. Because of the trade-offs Rust has made, and because of the fantastic Rust team at Mozilla, they've been able to make it such that there's no performance cost for translating your code to the compiled code. Other languages might have some inefficiencies when doing that step, and as a result, their code may not run as fast as it could. So what can Rust do for you? The first thing that comes to mind is safety. The compiler is so good that if it compiles, you can have a lot of confidence in the end product. It literally lets me sleep better at night, particularly before a demo or a production push. Rust is extremely cross-platform. Native, web clients, server, embedded system software can all literally be running off the same Rust code. If you ever want to have a single source of business logic using multiple platforms and multiple programs, this is it. Rust makes the hard easy. It's hard to highlight the major benefits in a hello world, but as you progress into a real application and the complexity of the problems you're trying to solve become harder and harder, Rust really starts to kick in. I don't think Rust really helps you get up easy, basic programs, but when things get tough, Rust really shines. It narrows the gap between junior and senior developers. It ups everyone's game where they're quickly writing strong, reliable code. Instead of relying on exhaustive and tedious code reviews to weed out rookie mistakes, the compiler does a lot of that for you. It enforces consistency. Many languages give you somewhat looseness around coding standards. For example, casing conventions on function names, variable names, structs, and so on. Other languages often treat it as a suggestion, some vague recommendation or tribal knowledge that you only find out about after coding for some time. Rust is a bit more strict, which is a good thing for code consistency for the entire team. However, Rust does allow you to escape the standards if truly needed, so it's still flexible enough if you need to bypass it for whatever reason. It saves you time. As I'll discuss in a later video, software development is actually overwhelmed by the time taken for testing and fixing bugs. Actual development is the easy part and is a much smaller piece of the total development timeline and cost. Because the compiler is so strict and so strong, coding time goes up slightly, but the time needed for testing and fixing bugs plummets. In my experience, the end-to-end time becomes much, much smaller. And of course, time is money. That goes directly to any bottom line. As well, correctness is money, both regarding your client's appreciation for your product as well as production downtimes. Obviously, I'm a huge fan of Rust, but I know you'll become one too. As mentioned, the learning curve is a little more difficult than other languages, but the rewards are much higher. Once again, my name is Doug Milford from Lambda Valley. Thank you for letting me pontificate about Rust, and I look forward to seeing you next time.